In this video, we'll be looking at 1.7, an introduction to functions. So our central question will be, how do I find domain and range in a function? We'll have another essential question, which is, how does function notation work? So we're going to talk about domain and range in a function, and we will talk about how function notation actually works. So first we need a definition of a function. And a function is a relation where there is exactly one output for each input. Another way to think of this is no repetition in x values, but you can have repetition in y values. So say we're like listing points, you cannot have repetition in x values. If the x happens twice, or if there's two arrows coming off a singular x, or if in a graph you see a point that shares the same x value, then you know that it's not a function. But if you have a graph or a map or a list of points where there's a repetition in the y values, that's a function as long as there's no repetition in the x values. So for me, the easiest way to kind of look at these is to use these two ideas. I cannot have repetition in the x values, but it is okay to have repetition in the y values. So let's decide if these are functions. So I look at my input being my x values, and is there any repetition in my x values? And for a mapping, what that means is, do I have an arrow coming out of any x value, two arrows coming out of any x value? Well, 12 only has one arrow, 23 has one arrow, 30 has one arrow, and the 48 has one arrow. So as long as all the inputs only have one arrow in a mapping, this is a function. Yes, this is a function. Now, when I look at number 2, as soon as I get to the number 10, I see two arrows coming out of my x values. So that means there's repetition in my x's. If I were to list these as points, I'd have 10, 0 and 10, 1. So anytime there's repetition in the x values, not a function. So this idea of repetition makes it really easy when you're looking at points. I'm just focusing on my x values and just looking for any kind of, does an x value repeat itself? 1, -4, 3, 2. It does not repeat itself. The x values never repeat itself. This will be a function. And I can look at the y values, and then we see that 3 repeats itself, but I can have repetition in a y value. Repetition in the y value, don't care about it. I am only focused on my inputs or my x values. Number 4, is there any repetition in the x values? Focusing on that x value. Oh, repetition, 4 and 4. So I can say not a function. So we're just looking for that repetition in the x value. Number 5, looking for a repetition. 3, 5, 4, 3. Look, there it is. Repetition, not a function. Number 6, -1, 1, 3, 5. This is a function. I have no repetition in my x values. Don't care about the repetition in my y values. That's allowed. We're just looking for repetition in the x values, so this is a function. So some more definitions. This chapter is very heavy on definitions. What we're going to do is discuss discrete, and it's not domain, it's just discrete. A discrete graph or a discrete function is a function, so let's call it discrete function, is a function with a graph of points that are not connected. So that would just be like scattered points. Remember, not repeating the x value. So if I just have scattered points all over the graph, then we can say that that is a discrete function. A continuous function is a function with a graph that consists of points that are connected. And that would be something like a line. When we draw our lines, you just have we first plot out 2 points, and then we draw the line, and we have a continuous function. That line represents all the points that would make the equation true. Next we have our vertical line test. And the vertical line test is if any vertical line intersects the graph, if any vertical line intersects the graph more than once, it is not a function. And what that does is just points out that repetition in the x values. As soon as I draw a vertical line and it touches my graph more than once, think of a vertical line, like say I had a circle drawn on my plane, these 2 points right here have a repetition in the x value. So if I drew a vertical line through these 2 points, boom, hitting once, hitting twice, sharing repetition in x, not a function. Okay, let's turn to the back. So we will try to describe the domain and range. Is this discrete or continuous? Is it a function? Okay, so if we recall from our last chapter or last lesson, the domain represents all the possible x values, and the y represents all the possible y values. So let's talk about the x values. The domain is, we use our squiggly brackets, is we're going to go from -3, so my x's start at -3, and where do they end up? At 0. So I can say x's are in between 3 and 0. And then my range, well, what's the lowest y value? 1 to -3, so my range is -3, and I'm talking about my y's are in between -3 and 1, 2, 3. 3. So we're just looking at where does my x value start? -3, and where do they end? 0. Where do my y values start? -3, and where do they end? 3. So that's how you can describe the domain and range. Now, do I have a scattering of dots, or do I have a line that's connecting a bunch of stuff? Well, we have a line. So we can call this a continuous function. We'll call it continuous. And is it a function? Is there any repetition in the x values as I travel this? If I drew vertical lines, would I ever touch the graph twice? No. So we'll say this is a continuous function. Number 8. Our domain. Well, since on this problem, when we're looking at it, I have very specific x values. It can't be any x value. On my previous one, at number 7, x could be -3, or x could be -2.5. X could have been -1.1. X can be any of these values, because that's what the connected line means. These dots mean I only have these specific x values, so we'll just list them. The domain is just the set of, well, what are my x values? I have 1, 2, 3, 4, and 5. I'm just pretty much grabbing the x values from each one of those points. 1, 2, 3, 4, and 5. So the range will be, we're just going to grab the y values from each point. Try to go in numerical order, so range kind of goes from bottom up. So I will start with, I have 1, I'm going up. So if I look at this point, the y value is 1, y value is 2, y value is 3, y value is 4, y value is 5. So it's very important that we realize that, yeah, these points represent, these points have different representations, and I'm not just copying the domain and range. I'm actually grabbing the x values for my domain, x value of each point, and the y value for each point. And do I just have scattered points, or do I have a continuous connected line? Scattered points, so we'll say this is a discrete. And do I have any repetition in my x values? Nope, so it is a discrete function. Okay, let's look at number 9. We can describe the domain and range of this. What's the furthest left x point? Well, if I look over, I go 1, 2, 3, 4. I have a point at -4. Less than or equal to, x is in between. X can be any of these points, any of those values. So x is in between -4 and 0. These needed equal signs up here. And what's the range? We want to go find the lowest y value. That's going to be right here. And I'm trying to get to the highest y value. So the range would be, if I'm looking for my lowest y value, I have -1. And we're talking about our y's are in between -1 and 1, 2, 3, 3. Now, this is where using that vertical line test helps us decide if this is a function. If I draw a vertical line, does it pass through 2 points on my graph on the circle? It does. So while this is continuous, all my points are connected, a nice smooth line, it's continuous, but is it a function? Failed the vertical line test, failed passing through 2 points, so not a function. Number 10, we'll talk about our domain. Now, this one's interesting because our lines go off forever in both directions. So if it's going on forever in the negative direction, and I'm talking about my x values, it's going on forever. You can picture it I'm grabbing all the negative x's. I'm grabbing all the negative and all the positive x's. So I can say x is all real numbers. Because x can be anything. This line goes off forever to the left and forever to the right. But my range is a little bit different. Because when I look at my range, y actually has a starting point. Let's make that point touch so it's a little bit easier to identify it. So what is the lowest y point? -2, but then it goes up forever. So how would I represent starting at -2 but then having everything that is greater than -2? Well, I can say I'm greater than or equal to -2. I have all the points that are greater than -2. If we look at this as it goes on forever, all those points are available. Now, does it pass our vertical line test? Well, if I drew vertical lines, does it ever touch the graph twice? No, it only touches once there, once there, once there, once there. So no matter where I draw a vertical line, at any point, anytime I draw a vertical line, it only passes once. So we can say it passes. So it is a function, and it's all connected dots, so we'll say continuous function. So function notation is simply, and this is going to be kind of weird, all it is it's giving us the ability to tell me exactly what number I'm plugging in. So we can think of it as, if we exchange the y for f of x. This is not f times x. I cannot stress this enough. F of x is not f times x. We're not multiplying f and x together. It's a notation that tells me a number that I'm inputting into my equation. But I wanted to point out that it's the exchange of, we exchange the y for f of x, because when we're graphing, say I want to graph a function, I just turn this piece, the f of x, into y. So they can go back and forth. So for example, if I had y equals 3x plus 2, I could rewrite that as f of x equals 3x plus 2. And I could rewrite it the other way. I could rewrite it both ways. So say I'm asked to graph this function. How do I graph this function? Well, I'm just going to treat it like a y equals mx plus b and graph it. But how does this function notation work? Well, what we do is we take the value that's right here, and we're just going to plug it in for x. So I'm given that f of x equals negative 4x plus 7. So when I change this x to 2, that means this x changes to 2. So I will write f of 2 is equal to negative 4 times, what does my x turn into? My x turned into 2, so this x turns into 2. And then I'll add 7. So this notation is just simply telling me how to give me a shorthand way of plugging in a number. That's all we're doing. So I'll say f of 2 is equal to negative 4 times 2 is negative 8 plus 7, and then we'll say is equal to negative 1. So we found that f of 2 is equal to negative 1. Let's do another example. It's the same process. This x has turned into negative 5, so that means my x in my equation is going to turn into negative 5. So I'm saying f of negative 5 is equal to negative 4 times negative 5 plus 7. So we'll multiply, and I have f of negative 5 is equal to negative 4 times negative 5 is 20 plus 7. So when my function has a negative 5 plugged into it, I get 27. So on these next two, all I'm really going to do is plug in my negative 3 into my function, and then whatever I get as an output after I plug that negative 3 in, I'll add 1 to it. So we'll have f of negative 3 is equal to negative 4 times negative 3, and then plus 7, and then I end up adding 1 to it. There's my x turning into negative 3, and then I add 1 to that. So here's the original function that I started with. Negative 4 times negative 3, negative 4 times x, plus 7. There's my function, then I'm adding 1. So I get negative 4 times negative 3 is 12 plus 7 plus 1. So f of negative 3 is equal to 19. Then I'm adding 1. So we have f of negative 3 is equal to, so f of negative 3 plus 1 is equal to 20. This is my f of negative 3 part. This is my f of negative 3 part. And then I'm adding 1 once I find that out. So we're going to stop right here. So that's how we can describe functions, describe the domain and range of functions, use some new definitions, and then how we kind of use this function notation. Thank you for watching this video, and I hope you have a great rest of your day.